Okay.
This is Cameron Chai here from azom.com, and I'm speaking to Ulf Nobben from Malvern Instruments, and he's going to take us through the Zetasizer Nano.
Hello there. Yes, this is the Zetasizer Nano from Malvern Instruments, and I'd like to point out to you what this instrument can do. It's a system that does dynamic light scattering, measures samples in various cuvette types. You have very low volume 40 microliters, 100 microliter, and 1.5 milliliter cuvettes for the sizing options. In dynamic light scattering, you can determine the size of colloidal particles, of molecules, proteins. For zeta potential, we have a special cuvette, and I actually have one in the instrument here. Point this out. This is a disposable and reusable capillary cuvette, where you inject your sample here into these two, undo these plugs, and just use a lure lock type syringe. Fill this capillary with about 0.75 milliliters of sample. You see these two gold-plated electrodes here. You apply a voltage to the sample, and the particles will move under the influence of an applied field, and you can, from this extra movement, determine what the zeta potential or effective charge of particles is. So we can put these plugs back in, and we'll put the instrument, put the cuvette into the holder. For a sizing cuvette, it's much easier. You just fill the sample into a little cuvette like this, with or without a lid. There's no sample in here right now, but once you fill it, there's a little easy graphics here on the instrument. You can determine that you have enough sample in there. Operation is very easy. You just close the lid, and in the software, hit a start button. I'm displaying some sizing results here for you. This is a mix of 60 nanometer and 220 nanometer polystyrene beads. And as you can see in the distribution here, this is the size distribution by intensity, showing us how much light intensity is scattered by the various size contributions from your sample. And you clearly see two peaks here, one at, well, roughly 60 nanometers and the other one at 220. We can look at the real results up here in the special report, and it shows us that peak 1 is almost 90% by intensity. The majority of the signal comes from peak at 230 nanometers, and the small peak, less in intensity, is 11.5 nanometers. Other example results, you can look in the records view. Let's look at a zeta potential result, just to show you what you get out there. Again, I'll just put the screen down a little bit. You can see the amount of light scattered for the various species contributions, basically from the different particle charge contributions. So here we have a single peak. Peak is at about minus 68 millivolts, and the standard that we used here was 65 millivolts, so it's within the standard deviation of the product that we're looking at. So the instrument is really easy to use, can do size and zeta potential measurements. It's been a very successful product for Malvern, and we are very happy with the use of the instrument in the biotechnology industry, polymer research, colloidal research, and general protein and particle characterization.
And Ulf, for anybody who's not sure about what zeta potential does, what's the relevance of that?
Zeta potential is used to find out more about stability of colloidal formulations, pharmaceutical formulations. It's a tool that gives you an idea of how stable particles are in solution. When they're very charged, they repel each other, so they don't like to get close to each other. They stay apart. You have a stable solution. When they're almost zero charge, should they happen to bump into each other accidentally, they will just stick together permanently. And so you just get a big bunch of aggregates, and the whole thing is not stable, falls out of solution, and that's what you want to avoid.
All right, Ulf, thanks very much for your demonstration of the Zetasizer Nano and your technical information.
Thanks very much. Bye-bye.